Hey, in this tutorial we're going to be looking at some applications. Okay, we've seen a lot of applications as a modelling section earlier. Okay, so I'll just look at a couple of worked examples. Okay, and then we'll get cracking. So the first one is quite wordy, so I haven't written it all out. Okay, we have if P dollars is invested into an account that earns interest at a rate of R for T years, and the interest is compounded continuously, then we get A equals P e to the RT, where A is the accumulated dollars. Okay. A deposit of $6,000 is invested at the Western Bank and $9,000 is invested at the Common Bank at the same time. Western offers compound interest continuously at a nominal rate of 6%, whereas the Common Bank offers compound interest continuously at a nominal rate of 5%. How many years will the two investments be the same? Okay, so what we need to do is we need to set up our two accounts. So what we're going to do is say our Western Bank, okay, we have A, and the amount that we investing was 6,000, okay, that's our P or our principal value. E and our rate was 0.06 times T, because it was 6%, okay, and our Common Bank A equals 9,000 e to the 0.05 t. Okay, because we were 9,000 investing and an interest rate of 0.05 or 0.5%. Okay, and we want to find out when these, okay, are going to be the same amount of money. Okay, so basically we've got to solve them simultaneously. Easiest way is the direct substitution of this A value in for here to make them equal each other. So we'll have 9,000 e to 0.05 t equals 6,000 e to the 0.06 t. Okay. So what we can do here, okay, is we can divide by 6,000 to get 3 on 2. E to the 0.05 t equal e to the 0.06 t. Okay, and what we can also do, okay, is divide our 2 here. Okay, so what we're going to do is go 3 on 2 equals e to the 0.06 t over e to the 0.05 t. Okay, remembering our index laws, when we're dividing numbers with the same base, we subtract the indices, which means we're going to be left with e to the 0.01 t. Okay, and what we can do here is we can do our loopy method, okay, and say log to the base e of 3 on 2 equals that. And say log to the base e of 3 on 2 equals 0.01 t. Okay, and we could divide by our 0.01, okay, and say, I'll do it over here, our t equals log to the base e of 3 on 2 over 0.01. Okay, and that's our exact answer. Okay, but when we get that, we get that 0.4055 over our 0.01. So t equals 40.5 years. Okay, so it's just a matter of setting up our equations. So we've got one more that we can look at. So a coroner uses a formula derived from Newton's laws of cooling to calculate the elapsed time since the person died. The formula is T equals -10 log to the base E of T minus R over 37 minus R. Okay, so little t is time in hours. Okay, and that's since the death. T is the body temperature measured in degrees Celsius. Okay, R is a constant room temperature. Okay, and so we've got everything that we need. Okay, an accountant stayed late at work one evening and was found dead in his office the next morning. At 10 a.m, the coroner measured the body temperature to be 29.7 degrees. Okay, a second reading at noon found the body temperature to be 28 degrees. Assuming that the office temperature was constant at 21 degrees, determine the accountant's estimated time of death. So what we're doing here, okay, is we're going to set up some simultaneous equations. Okay, so that we know, okay, that at 10 a.m, we're T equals negative 10 log to the base E of our temperature of our body, which was 29.7. Take the room temperature, which was 21 degrees, over 37 minus the room temperature. Okay, and we can say that that is equal to negative 10 log to the base E of 8.7 over 16, which is equal to negative 10 log to the base E of 0.54375. Okay, which means that we're looking at it being 6.09 hours. Okay, so it looks like we're going to be about that amount of time. Okay, but we need to have a look at the other temperature as well. So our T equals negative 10 log to the base E. Our other temperature was, let me just double check here, 28 degrees. Minus our 21 over 37 minus 21. Okay, which means we get log to the base, negative 10 log to the base 7 on 16, which equals negative 10 log to the base E of 0.4376, okay, which is equal to 8.27 hours. Okay, so you can see we've got a little bit of discrepancy there. Okay, and when we determine the time for each of those, okay, we actually get that we are between 3:44 and 3:55 a.m. Okay, so you get a reasonably accurate range of times there. Okay, so that's everything that I can show you for the application section. So this is the last section of chapter 4. Okay, so just remember some things along the lines of, if we want initial conditions, that's always when T is going to be equal 0. Some of those things that we've looked at in the past.